Hi, good morning to one and all. Welcome to MSc second year, second semester's chemistry, Karnataka State Open University. In this module, I am going to discuss with soft core SCT 201 paper. Entitled of this paper is Chemical Spectroscopy. This paper, the chemical spectroscopy, is classified into 4 different blocks. In block 1, discuss the microwave spectroscopy. In block 2, vibrational spectroscopy. In block 3, Raman and electronic spectroscopy. Finally, the optical and electrochemical spectroscopy. In that first unit, we have to learn what is the relationship between energy and matter. Because all spectroscopic techniques, it depends on this what energy and matter. The properties of this matter, wave properties of light like reflection, refractions, diffractions, interference, and particles properties of light, photoelectronic effect, X-ray diffractions techniques, and the common Compton effect, dual nature of electron, electromagnetic radiation, and characteristics of these electromagnetic waves like amplitude, wavelength, velocity, frequency, etc. We know that Einstein energy equation. Einstein gave a energy equations. E is equal to mc square. Similarly, in 1900, by considering the Bloch body of radiation by Max Planck, gave that energy equation. That energy is what? Product of Planck's constant and frequency of the radiation. Anyhow, we know that Planck's constant value 6.63 into 10 to the power of minus 34 joule per second. Mu is frequency of the radiation. In that quantum mechanics, the mathematical formulations of the quantum theory was developed during the 1920. Later, that is modified by that Louis de Broglie, C.J. Davison, L. at Germer, and Erwin Schrödinger, Werner Heisenberg. These are all the scientists to work out the concept of what? Wave. Ultimately, with the help of this classical physics, finally we got the relationship between that energy and matter. That is what here E is equal to h mu. The individual bundle or packets of energy, that is called what? Quantum or quanta, behaves in some situations much like particles of matter. These particles are exhibited wave-like properties when in motions and are no longer viewed as localized in a given region, but rather as spread out to some degrees. What is that properties of matter or particle? There are 4 different types of matters are there. You are also well known that they are weight, volume, mass and density. Among these, the most important properties of matter is mass. Mass means the amount of matter in an object. It never changes unless matter is taken out from the object. Volume is the another property of this matter. The SI unit for this here meter cube means length into breadth into height. The third property is density. Density means that is mass by volume expressed in that in Cbcs system gram per centimeter cube and in MKS system that is kg per meter cube. The properties of waves we consider that reflections of some boundary and some transmissions. The transmitted wave undergoes reflection, means that is bending, if it approaches the boundary at an angle. If the boundary is nearly an obstacle implanted within the medium. Here, that wave it behaves like that, either reflection, refractions and diffraction is characterized by that scientific conceptual principles and mathematical equations. Next, we'll discuss on the properties of light. Light exhibit behaviors that are characterized in both waves and particles. The certain behaviors of light that are characteristics of wave would be difficult to explain with a purely particles wave. Means light reflect in the same manner that any wave would reflect. Light refract in the same manner that any wave would refract. Light diffract in same manner that any wave would diffract. Light undergo interference in the same manner that any wave would interfere. The definitions of these reflections. When light wave incident upon the surface, the particle light is bounced back is called what? Reflected light, and the phenomenon is called what? Reflection. Just we consider that diagram. This is incident rays, this is reflected rays, this is refracted rays. Refractions means is the bending of a light wave when it enters from the one medium to another medium. If the speed of light is different in two mediums. When light passes from fast medium to slow medium, bending of the light waves towards the boundary between the two media. With the help of this Snell's law, we can calculate the refractions value of that light. That diffractions, when light bends, when it passes around an edge or through a slit. This bending is called diffractions. The amount of bending depends on the wavelength of the light and the size of the opening. Next we consider that interference. When two sets of light combine with each other to produce a resultant wave, the way in which this combined wave is produced is called interference. Next we consider the concept of this word here, photoelectronic effect. When a photon of energy, that is what, h mu, strike an electron inside a metallic conductor, it cannot be electron out of the metal. Means when a suitable frequency of light is falls on the metal surface, that is called what? Photoelectric effect. To explain this effect, Einstein claimed that light was made up of particles called quanta, that each had some small fixed energy which depended on the wavelength of light. The shorter the wavelength, the more energy of each of these quanta had. The longer the wavelength, the smaller the energy of quanta. So quanta of red light would have less energy than quanta of blue light. That is X-ray diffraction technique. X-rays are high energy photons that are produced when electrons make transition from one atomic orbit to another. These transitions can be generated via the photoelectric effect. An electron in an alternating electromagnetic field will oscillate with the same frequency as the field. This is the concept of this what? X-ray diffraction. In that Compton effect, the elastic scattering of photons and electrons from electrons. Compton found that when the monochromatic X-rays are illuminated on graphite, the wavelength of the scattered X-rays will be longer as the scattering angles becomes larger. This is called what? Compton effect. Consider the dual nature of electron. Here two scientists, they have delivered the mathematical expressions of this what? Energy. According to that, Einstein's mass energy relation is written as A is equal to mc square, and Planck's energy equation E is equal to h mu. Here comparing equation 1 and 2, here h mu is equal to mc square, here mu is equal to c by lambda. Substitute here. Here cc get cancelled, here lambda is equal to h by mc, or lambda is equal to h by p. P is called what? That is momentum, the product of mass into velocity, that is called what? Momentum. That electromagnetic radiation. Electromagnetic waves are produced by accelerating charges. From our elementary study of the physics, we know that moving charge particles generate an electric field around it, and an oscillating electric field generates an oscillating magnetic field, and vice versa. The electromagnetic waves is defined as the wave consisting of electric and magnetic field oscillating at right angles to each other and perpendicular to the direction of propagation. Next we will study what are the characteristics of these electromagnetic waves. Electromagnetic waves, transverse waves similar to water waves in the oceans. Consider that amplitude, wavelength, velocity and frequency, these are all what characteristics of these electromagnetic waves. Amplitude means here electromagnetic waves relates to the intensity or brightness. With the visible light, the brightness is usually measured in luminous intensity. Next we consider wavelength. The electromagnetic waves go from extremely long, extremely short, and everything in between. The wavelength determined how matter responds to the electromagnetic wave. The velocity of electromagnetic waves in vacuum is approximately 1,86,000 miles per second or 3 lakh kilometers per second. That is the same as the speed of light. When these waves pass through matter, they slow down slightly according to their wavelength. Next, frequency. The frequency of any wavefront equals the velocity divided by the wavelength. The units of measurement are in cycles per second or hertz. Now I am going to conclude this unit. The nature of electron seems had the different points in time, but it is impossible to say where the electrons will be at a given time. Just as the light is brought to have a dual nature, sometimes showing the characteristics of a wave and sometimes that of a particle, quantum theory attributes a similar real wave particle nature to subatomic particles. To explain all experiments with electromagnetic radiations, one must assume that light can be described both wave and particles. Different theories that is explained. Now Louis de Broglie gave that quantitative relationship between that wavelength and momentum. These are all the summarized that unit 1. These are all important questions. Mention they describes the 3 wave nature properties of light. Explain the wave particles properties of light. What is dual nature of electrons? And how to derive the de Broglie wave equations, electromagnetic radiations, how it is produced, what are the properties of electromagnetic radiation.